Hello everyone, it's time for a new video using Laplace transform now to solve systems of differential equation. Isn't that neat? All right, let's get this started. Let me make this a little bit smaller and let me put it higher over here. And let's try and rewrite this in a more compact way. So let's say that this left part is going to be x prime, or I'll do x dot because it's with respect to time. This is the engineering notation, is equal to x minus 2y. And here we have y dot is equal to 5x minus y. Okay, well, now that we have this, let's apply the Laplace right away. So we're going to apply the Laplace transform, the Laplace transform to both sides of each equation. So the Laplace transform of x is going to be big X. Remember, now it's a function of s because we're in the s domain, but this is a derivative. So it's not just going to be big S, it's going to be s times big S minus small x of 0. And this is where we would plug our initial condition, which they gave to us. On the right-hand side, the Laplace of just x is going to be big X of, not t, of s minus 2, because they have linearity properties, so the constants can be factored out, y of s. Now we're going to do the same thing with the other function. So that's going to be the big Y of s times s, because it's the derivative, minus y of 0. And this is where we put the other initial condition that they gave us. And here at the bottom, we would have 5 times this big XS minus, then we have our YS. Okay, so now that we have this, the first thing I would do is let's plug these initial conditions. So this one is -1. So we'll plug that in. Remember that there's a negative in front. And this one is going to be a 2. Okay, so now we're going to try and solve for xs and xy. And I'm going to drop the s's for the function notation to make it a little bit easier to read. So what do we have over here? Well, if I, on the top one, if I subtract xs to both sides, I have s times big X minus x. Remember, these are functions of s, but I'm not gonna write that s. And now we have that negative minus 1, which is positive 1, which we bring to the other side, so that becomes, again, -1. And then we have minus 2 times our big Y. Now let's go over to the bottom and let's do this, a similar thing. We add y, the big Y, to both sides, so we get s times big Y plus big Y right here. And all of that is going to be equal to, we have that -2, which we bring to the other side, so that's going to be positive 2 plus 5 big X. Now we can factor out from here, we can factor out the big X. So let's do that. Let's factor out this big X and Y. We're going to get s minus 1 times big X equals to -1 minus 2y. And s plus 1 times big Y equals to 2 plus 5 big X, and I want to write the big Y here. Okay. Well, now we can solve for x and y. So what is this going to be? Well, if I solve for x here, I'm gonna get that my x is gonna be equal to -1 minus 2y over s minus 1. So I got the y in there, so I can't solve it yet. I need to input this into here. So now I can say that my big Y is equal to 2 over s plus 1 by dividing by this on both sides, plus 5 over s plus 1 times s minus 1. I'm substituting in what I have. Minus 1 minus 2y. So now I realize, wait, I actually need to solve for y again. So let's use a different method to make it a little bit less painful. So if we take all of this and we just write it in a different way. So now that we have these, what can we do? Let's write them in standard form. So s minus 1 big X plus 2y is equal to -1, and s plus 1, well, no, let's write the x's under the x's, minus 5 big X plus s plus 1 big Y. All of that must be equal to 2. So what we do here is let's multiply this top row by -5 and the bottom row by s minus 1 so that I can cancel the x's. So I'm going to say this, I'm going to multiply this by -5. I have to multiply the whole left-hand side and the whole right-hand side. And here I'm going to multiply this by s minus 1 here and here. So what am I going to get? I'm going to get, let me make a little arrow here. I'm going to get minus 5 s minus 1 big X plus 2 big Y equals to 5. And here I'm going to get minus 5. Now you see why I did it. S minus 1. So I should have multiplied the top by a positive. And then I forgot to multiply here. So that's going to be plus, because now I'm saying I'm multiplying it by a positive 5. So that's going to be 10 plus 10y equals to -5. Here I have the negative big X plus, we'll need a little bit more space because this is going to be a big coefficient. We're going to have an s plus 1 and an s minus 1 times y, and that's equal to 2 times s minus 1. So now if I add these two together, what happens? Well, now what happens is that these two cancel out completely, and so we're left with s plus 1, s minus 1, and 10. So we have 10 plus all of this business in the y. And here we have 2 times s minus 1 minus 5. So we can say that our y is equal to 2 times s minus 1 minus 5 over 10 plus s plus 1 times s minus 1 here. And we solved for our y. Now we can do a similar thing for the x. So say we multiply the x by, so we get back to this. So let me copy that. And I'll paste it over here because I want to show you we're doing the same thing twice because we don't want to deal with substituting back in. So here, I'll put a division and we'll say, what do? I'll multiply. If I want to, well, I actually want to copy a different thing. I want to copy the next step. So let me copy this step right here. Copy and paste. Copied and paste right here. But now I don't want to cancel the x, I want to cancel the y. So let's see, what can I multiply by to cancel the y? Well, if I multiply the top by s plus 1 and the bottom by -2, that should do it. So s plus 1 here, s plus 1, and the bottom by -2. Let's see. Well, in this case, we would get s plus 1 times s minus 1 times big X plus 2 times s plus 1 times big Y is equal to negative s plus 1. And on the bottom, we have positive 10 times big X. And then here we'd have minus 2 times s plus 1, y equals to negative 4. Now, if we are to add these two together, what we get is s plus 1 times s minus 1 times 10. And all of this is going to be times the big X right here. And then here we're going to have, this just cancels out. And that's all going to be equal to minus 4 minus s plus 1. So if I now solve for x, I get minus 4 minus s plus 1 over s plus 1 times s minus 1 times 10. Now, what I want to do with these two things is I want to decompose them into partial fractions. So part frac. And sometimes this can get a little long. So I suggest using a computer for this, and I use MATLAB. So let me put this real quick in MATLAB and let's see what happens. So if I put this in MATLAB, I'm gonna get, I have to use the part frac command, open parentheses, and say 2 times s minus 1 minus 5. All of that should be divided by, so let me open a parenthesis, close a parenthesis, all of that should be divided by open parenthesis, 10 plus open another parenthesis, s plus 1 times s minus 1. And then we're going to do the same thing for x. So this is our y of t. And then we're going to do the same thing for our x of t, where the denominator, I think I made a mistake in the denominator here. See, these should be added together. So here we get plus 10. So this should be plus 10 right here. And now, so the denominators are going to be the same. The numerator is going to be negative 4 minus 4 minus s plus 1. So now that we have inputted all of these things, we can press Control Enter. And we get these two partial fractions. We get, let's see, for the y, we get 2s minus 7 divided by s squared plus 9. On the right, we get s plus 5 divided by, and here we want a negative in front, s squared plus 9. So now that we have all of this, what we want to do is we want to convert them into a form that would be useful, that we could invert again. So what would that be? Well, if I go over here, if I look at the table that I have, it seems like we have an s squared plus something. So an s squared plus something, we could rewrite this top one as 2s, or we could rewrite this as 2 times s over s squared plus 9 minus 7 times 1 over s squared plus 9. And this seems to be almost fitting a pattern. So for this one, we can almost apply the Laplace inverse. Now here, I'm going to write s over s squared plus 9 with a minus 1 in front. And then we have a 5, and here we have a 1 over s squared plus 9. Now that I have this, what I'm looking at is, if you look at the Laplace tables, you're going to see that there are two columns, one for f of t and one for its transform, big F of s. And you're going to see that there's one in particular that has cosine of kt is, if you apply the Laplace, you get s over s squared plus k squared. And then sine of kt, you get k over s squared plus k. Now, if you look at this, we may have something like this. You see how we have the s in the numerator here and the s plus 9 here? So if I apply the Laplace inverse, let me first rewrite everything. So I'll have y is equal to 2 times, now I want to apply the Laplace inverse to everything. So let's apply it to the big Y, and let's apply it to this. So it's going to be the Laplace inverse of 2s over s squared plus 9 plus the Laplace inverse of 1 over s squared plus 9. And then at the bottom, so if I look at this one, I'm going to say that the Laplace inverse of the big X is going to be equal to the Laplace inverse of what? Of s plus 5. No, I wanted to decompose it. So minus 1 times s over s squared plus 9 plus 5 Laplace inverse of 1 over s squared plus 9. So now that we have this, let's realize that by the properties of the Laplace, I can pull the constants out. So I'll pull the 2 out, and I'll pull the negative 1 out. And here the 5 already pulled it out. And then I realize, well, this pattern matches this pretty well. So my k is square root of 9, which is 3. So I can say right away, and I think this is the same thing. So I can say right away that now the Laplace inverse of the y of s is going to be small y of t. And here I can already say 2 times the cosine of square root of 9, which is 3 times t. And with the other part of the Laplace, I need to, it looks like it's going to be, so this one is this guy right here, but it looks like this one could be this one if only I had the k on top. If only I had the k on top. And I forgot to put a square here as well. So this is squared. If only on top I had the square root of 9. Well, I could do something here. I could multiply by 3 and divide by 3 and then bring that division by 3 out. So that I really just multiplied by 1, but now I can apply that transformation. And so I can say that this is going to be 1/3, and now I match it completely with the sign. So times the sine of the square root of 9, which is 3 times t. And now at the bottom, we're going to have the same thing. We're going to have the negative that's in front, cosine of 3 times t, plus 5/3 times the sine of 3 times t. And this should be our answer. So you see how maybe it was a little bit longer than other methods, but it's definitely less demanding because it uses algebra. And so you don't really see a lot of integration or using other methods. It's just algebra and keeping track of your things. I'll show you how to do this one in MATLAB real quick in part B. See you there.